Today we will be discussing about Newton-Rhapson method or the Newton's method of tangents. So Newton-Rhapson method is one of the most widely used method for solving the roots of equations because of less number of iterations required to solve for the root. It is more convergent than any other methods discussed so far. And this method is based on linear approximation of the function, but does so by using tangent to the curve. So starting from a single initial estimate of x0 that is not very far from the root, we move along the tangent to its intersection with the x-axis and take that as the next approximation. So our value of the next x will be the initial value of x minus the value derived from the function of x over the derivative of the function of x. So f prime denotes the derivative of the function of x. So here the prime here denotes the function of x. So to fully understand the Newton-Rhapson method, let us consider this example. F of x equals 3x plus sine x minus e raised to the x. We are required to arrive at an error of 0.00001 and the initial value given for xi equals 1. So first, here are the steps. So in the previous slides, we know that to get the next value of xi, we need to get the value of the derivative of the function f prime x. So the first step is to get the derivative of the function of x. So our function of x is equal to 3x plus sine x minus e raised to x. So what is f prime of x? What is the derivative of 3x? What is the derivative of 3x? The derivative of 3x is 3. Next, plus, what is the derivative of sine x? The derivative of sine x is positive cosine of x. Derivative of x here is 1, so cosine x dx. So it's okay. And minus, what is the derivative of e raised to x? The derivative of e raised to x is still e raised to x, and the derivative of our exponent x here is still 1, so no need to write. So f prime x is this one. That is what is reflected here in the equation f prime x. Again, to solve for the next value of xi plus 1, or the next value of x, it will be xi minus the value derived from the function of x if the value of x is substituted to the equation divided by the value of the derivative of the function of x. So let's complete the table. Here, from the given, we are given as 1 as our xi. So that's why our xi there is 1. The original equation is, this is the original equation, 3x plus sine x minus e raised to x. So f of x is 3x minus sine x, again, plus sine x minus e raised to x plus sine x minus e raised to x. If we will substitute the value 3 times 1 plus sine of 1 minus e raised to 1, that will give us 1.12318,916. That value is that one. Our next column is for the derivative f prime x. So what is our f prime x? That is equal to 3 plus cosine x minus e raised to x. That is this equation. So we will substitute 3 plus cosine of 1 minus e raised to 1. That is equal to 0.82202048. That's is the equation or the value in this table. Then what is the value of xi plus 1? The value of xi plus 1 is equal to xi minus the value of f of x over the value of f prime of x. That will give us 1 minus parentheses 1.12318,916 divided by 0.822024. So that is equal to negative 0.3663761. So this is the value naman from this column. And the error is equal to xi plus 1 minus xi. That is the absolute value of xi plus 1 minus xi. So that will be the absolute value of xi plus 1, that is negative 0.3663761 minus 1. So that will give us absolute, so 1.3. The answer here is negative 1.3663761, but since it is absolute, the answer for the error is 1.3663761. So that is the value here. So you just have to repeat the process, you fill up all the columns until we reach the required error. So you will notice that in using Newton-Raphson method, we arrived at the derived error only after 4 iterations. So it's very short compared to the previous examples that we had, that we have at least almost 12, 15, or 20 iterations. But using Newton-Raphson's method, we can easily get the root of the equation, say after 4 iteration only. But what is the root of the equation? So the root of the equation, or one of the roots of the equation, is the last value of xi plus 1 that you have derived. So what is the last value of xi plus 1? That is 0.360417. So that's why the root here is 0.360417. So Newton-Raphson is a very easy method to utilize in solving for the root of the equation. So thank you very much, and see you with our next topic.